Hello students. In this video, we'll learn about the optics density-based clustering algorithm. This optics refers to ordering points to identify the clustering structure. So it generally considered as an extended form of DB scan, where it uses a hierarchical approach. Now, this optic clustering will require only the minimal inputs, and it also uses the two parameters which is called epsilon and minimum points. And here we use two terms which is called the code distance and reachability distance. So using this code distance and reachability distance, we can identify the clusters which will have different densities or which will have different shapes. Finally, it generates a reachability plot which shows the density as well as connectivity of those data points. Using this reachability plot, we can easily interpret the clustering results. Now, as we have already discussed that we'll have here two terms which is called code distance and reachability distance. Let's understand what is this code distance. So here the code distance of a data point, it is the minimum radius required to classify it as a core point. So here you can see that we are in this example, we have the core point as P, right? So the core point which is within the epsilon radius and having the minimum points, that we call it as a core point, right? Now the minimum radius which is required to classify the core point, that we call it as a core distance. So here we have the radius of 3 mm which will satisfy the core point. So which can classify this core point, that we are calling it as what? Core distance. Then what is reachability distance is, here we have a distance P, and if you want to find the reachability distance of this P with another point Q, if the Q is a core point, then we say that it will have the smallest distance. If it is not the core point, the reachability of this, if suppose that here we are having Q2, and let us consider it is not a core point. When it is not a core point, it is not possible to find the reachability distance from P to Q2. So here, if you want to find the reachability distance from P to Q1, it is among the within the radius, right? So here the epsilon radius is given as 6 mm. So here we have it as what? 3 mm. Now the reachability distance from P to Q1, here Q is also a core point which is having the radius of 3 mm. Now suppose if you want to find the reachability distance from P to Q2, will basically consider the maximum value from core distance and the distance between this P and Q2. So let's understand this with an example. Let us consider a data set which is having 4 points. So initially, so we'll be following the same steps that we followed in the DB scan. Here also we need to find the neighborhood epsilon neighborhood points. So for that, we'll be calculating the distance between the all points which are available in the data set. So we can see that we, after finding the distance between A to B, A to C, and all the other points, we got some distance. And based on that distance, we have to place that in an order. So after sorting them in an order, A, B, C, D, B, C, these are the distance between AB is 1.414 and the distance between AD is 7.071. In this way, we have to place them in an increasing order. After sorting the distance, now we need to find out the core distance. So what actually is the core distance is distant to its nearest neighbor within the epsilon radius. So let us consider the epsilon radius here is 2. So in the DB scan, we have already seen that when it is less than or equal to that epsilon value, we consider that as a core distance, right? So here, when we look at the data after sorting, we can see that here we consider the epsilon as what? 2. So only the 2 points A, B and C, D, which is less than the given epsilon value, right? So only these 2 points were considered. So core distance of A will be AB and core distance of B will be the same AB, right? So core distance of CD, we got it as 1.414, and co-distance of CD is also 1.414. Now we have calculated the co-distance. Now we need to calculate the reachability distance. And to calculate the reachability distance of A to B, we'll be considering the core distance as well as distance from A to B. And we'll take the maximum value from that. Okay. So initially, suppose if we want to find out the core distance from A to B. So what is the core distance of A? Here we can see it is 1.414. And what is the distance from A to B? We have already calculated in the previous step. The distance from A to B is what? 1.41. So similarly, we got the distance also here as 1.414. So we need to consider the maximum number among this, right? So when we find, we can see that 1.414 is the maximum. So the reachability distance from A to B will be what? 1.414. In a similar way, we have to calculate reachability distance from A to C. So for that, when you are calculating reachability from A to C, we'll be considering the core distance of A as well as distance from A to C. So what is the core distance of A? It is 1.414. And what is the distance from A to C? Let's see from the previous table. So the distance from A to C is what? 5.66. So what is we need to take the maximum value from this, right? So here we have 5.66, and when we consider the maximum among this, 5.66 will be the maximum. So the reachability from A to C is given as 5.66. The similar way, we need to calculate reachability from A to D. So in this way, we'll be finding the reachability distance of AB as well as CD. So finally, using this reachability distance, we can find the clusters. So here, when we just draw a graph using this and plotting the reachability distance, right? So when we plot that, just assume that in the y-axis, we are having this reachability distance, and we can see that it is started reachability of A. We are starting from the first point. So it will be the infinity, the reachability of this, because you are not starting it, so the reachability of this will be infinity. Now A to B, the reachability is around some 1.414. Similarly, A to C, the reachability is around some 5.657. Again, we have 7.071. So in this way, the plot will, there will be the graph plot will be represented for this reachability distance, and whichever is data point is at the peak level, we consider that as the farthest data point. And if you are having some other data points which are nearer to this, so when you look at this A to B or B to A, and similarly C to D and D to C, we are having the same points, that is 1.414. So all these points will be in the at the same location. So we cluster them together. And whichever is the farther from this point, they are said to be clustered as another cluster, and they will be farther from the other data points. So if the point is at the peak level, we say that this is the farthest point, and if the point is at the valley level, we say that the distance or the density between those points is less. So in this way, we can form the clusters using the optics algorithm. Now let's understand about one more density based algorithm, which is called DENCLUE. So here DENCLUE, it is also a density based algorithm. And so before that, let's understand about the advantages and disadvantages of optics. So we know that DB scan cannot be used for the varying density. So the optics can identify the clusters with the varying density, and we need not to have the or specify how many number of clusters that is required. So when we compare to DB scan using this optics, we can find out more noise points which are available. And if we are choosing any larger data set, the computation task, it will be very complex. And here we have to select the minimum points as well as the epsilon radius value carefully, or else it will become computationally complex. And coming to the DENCLUE algorithm, so it is called as density-based clustering, and it is given by Hinberg and Kim. So here we use the various statistical density functions. So initially, we try to find out the density of each data point, and to find out the density of each data point, we'll be using the Gaussian function. And to improve the influence of that, we'll use Gaussian functions and some statistical density functions in order to improve its intensity. Then we'll find the global optima. Here we can see that the Gaussian function will help us in understanding the influence of 2 points like y on x. Suppose if you want to find out the Gaussian function of any x, and also the influence of this data point on other data points, then we can use this along with the sigmoid function. So here we also calculate the gradient of x with respect to the input data point which is given. So it will have a complex mathematical foundation, and it will be good for the data sets which has large amounts of noise. So because using all this mathematical foundation, we can identify the outliers easily. And then we can also identify the arbitrary shaped clusters which are present in the high dimensional data sets. So when compared to all the other algorithms like DBSCAN and OPTICS, density based clustering is faster. The thing is, it needs a large number of parameters. So just like the density DBSCAN and OPTICS, here also we'll use parameters which are called sigma and delta. And initially we'll be using a Gaussian function. This Gaussian function will measure the density around the each point. So to find the density, after finding the density using this density function, then we'll find the local maxima. So it means that using the gradient accent, we try to find out the points which are at the local maxima, and we'll cluster those points. And to find this point at the local maxima, initially the convergence, it is set to false. And if the points are not converged and the iteration count is less than the given maximum iterations, then we'll compute the gradient. So here the gradient is computed, and a new point is updated. And the updated new point is now checked for the convergence. If it is convergent, so this convergence is checked with the threshold value. The given new value plus the input, when you perform the difference between them, and if it is less than the given threshold value, then we say that the data points are converged. If the data points are converged, we'll set it as true, and we'll update this old input with the new input, and then we'll calculate the gradient. So here initially, after finding the local maxima, so we'll be assigning each point to the cluster which are present at this local maxima. So whatever the data points which are present at this local maxima, they are clustered together. So whatever the points which, suppose this is a convergence, local maxima convergence, and whatever the points that comes under this local maxima, they are clustered under the same, they are clustered into the, or they are grouped into the same cluster. So here the points which are having the lowest density, then the threshold, then they are considered as the noised points. Suppose if you are having a x point, if its point value is less than the given threshold value, then we say that it's an outlier and will not come under any convergence point or any local maxima point. So using this density based functions, we'll try to find out the clusters in DENCLUE. And coming to the advantages and disadvantages, so this DENCLUE is also helpful in finding the arbitrary shapes, and it will, when compared to DENCLUE, when compared to DBSCAN and OPTICS, DENCLUE finds the outliers correctly. And coming to the disadvantages, here also we need to be careful while choosing the parameters. And as it is involving density functions, if you are choosing the larger data set, the computation may be complex. And here sometimes it also liable to various local maxima issues. And most primarily it will be suited for the continuous data. So this is about density based clustering algorithms. Thank you.